Hi, we are Shravya, Yichi, and Jue. Here is our final report for the Wikipedia questioning and answering system. As for the pipeline of the system, we made some slight modifications to the one in the midterm report. For question generation, we first parse the input file into individual sentences and obtain the post text, named entities of the word tokens, and the sentence structure. Then we substituted part of the sentence to produce a what, who, when, where kind of question. Then we also modified sentences to make yes or no questions. We further implemented an evaluation mechanism to trim off the questions that are prone to error. The remaining questions are printed to the output and used for tuning our question answering system. For question answering, we also parsed the input file into individual sentences and used the original file as the training data to obtain the vector of each sentence through word2vec. Meanwhile, we check for the type of the question. Then we find the most similar sentences to the questions from the original file through cosine similarity, then locate the appropriate noun and output that as the answer. The main natural language processing package we use is spaCy. spaCy provides functionalities such as word tokenization, post tagging, named entity recognition, token dependencies, and cosine similarity. All of these come in handy for our use. Here are the details of our implementation for question generation. We parse the input file into sentences and obtain the post text of the word tokens. We also obtain the name entities and dependency structure of the sentence. Then we substituted nominal subjects with who, was, where, when, according to the entity tag of the noun. We also brought forward auxiliary verbs and negated randomly to generate yes or no questions. We further pruned the clause to make the question simpler in terms of structure and makes it more natural. Our evaluation mechanism voted out questions with multiple questioning keywords to avoid confusion. We also opt for simple sentences with no dependent clause. Questions where unresolved coreferences were also trimmed off. In this way, we ensure that the final output is both grammatically correct and answerable. As for the question answering, we first parsed the input file into sentences. Then we extracted question types by looking for the corresponding keywords, such as who, where, when, why, how, and how long. Then we used the original input file as the training data and vectorized the sentences through word2vec. We compared the sentence vectors with the question vectors and listed 3 most similar candidates from the original file. For each noun chunk within the candidate sentences, we checked the context with question as well as the question type that we extracted before to find the best match. If the matching answer is a pronoun such as he or she, an unresolved coreference occurred. We greedily searched within the paragraph where the candidate sentence belonged and gave the most frequent noun as the answer. Some questions are erroneous due to the incorrect entity tags. Some names are incorrectly tagged as location by spaCy, and the resulting questions becomes where instead of who. Such errors are hard to catch by a naive grammar checker. We believe that by training our own NER models with hand-tagged data could resolve the problem. We could also have implemented some grammar rules to ensure that the final output is grammatically correct and resembles the ones X by human.